Hey dear students, so the question for today's video is three charges are arranged as shown in figure. Find the magnitude and direction of the electrostatic force on the charge at the origin. Before we solve this question, let us first make a base to understand the question properly, and then we will start solving this. The first step is to know which charge is actually at the origin. So the charge right here, let's just call this charge A. For our convenience, this charge B, and it is our charge C. So the charge that we have called A is basically at origin, and we need to find out the electrostatic force that is acting on this charge A. But before that, we need to know how many forces are actually there that are acting on charge A. So there are basically two forces that are acting on charge A. The first force is the force that charge B is exerting on charge A. We will call that force FBA. And the second force is the force that charge C is exerting on A. We will call that force FCA. So we know that according to Coulomb's law, what is Coulomb's law? F equals to K Q1 Q2 over R square. So if we apply this Coulomb's law on the charge F on charge B and A, what we will get? We can write FBA equals to KE, that is constant, QB QA over R square. Now if we see everything is known, we know the magnitude of charge B, that is QB, we know the magnitude of charge A, that is QA, and we know the distance between the two charges, that is 0.3 meter, and K is constant, that is 8.9 and exponent 9. What we need to do is we need to substitute these values in standard units and calculate FBA. So after substituting the values in standard units, we get FBA is 3 exponent minus 6 Newton. Now let's calculate the second force, that is FCA. So for calculating FCA, we know the Coulomb's equation will be KE QC, the magnitude of charge C, QA, the magnitude of charge A, over R square. So everything is known here as well. What we need to do is we need to substitute the values. We know the magnitude of charge C, magnitude of charge A, and the distance between the charges. We only need to substitute the values as we substituted previously for these in standard units, and find out the force that FC is exerting on charge A. So this is the calculation for force FCA. Now the next task is to find out the direction of these two forces. For that, we need to focus on this diagram. See, the charge B is positive, whereas charge A is also positive. So the charge B will push away charge A from it. So the direction will be like this. This is my force FBA. Whereas charge C is negative and charge A is positive, so charge C will attract charge A towards itself. So the direction of force FCA will be like this. So these are the two forces. We need to find out the resultant of these two forces to know what is the electrostatic force that is acting at the origin. So just make a separate diagram of this for our convenience in head to tail fashion. So the diagram will be like this. This is my charge. This is my first force, that is FBA, and in head to tail fashion we need to drag this force FCA here, because we know the tail is connected to the head. So this is my force FCA, and we know the resultant is drawn from origin to the head of the other force. Excuse these arrows, and this is my theta. So we need to find out this resultant, and for this resultant what we can do is we can simply apply Pythagoras theorem and find out the resultant force that is acting on the origin. So it is when we will apply Pythagoras theorem, we know Pythagoras theorem is R is FBA force square plus FCA square. We know FBA, we know FCA, we have find out here. We only need to substitute these values in our calculator, and when we will do it, we will get resultant 1.38 exponent minus 5 newtons. So this is the electrostatic force that is acting at the origin. Now for the direction, we know that we can apply tangent theta. So we know tangent theta is opposite over adjacent. So opposite is FCA over adjacent is FBA. For theta, what we can do is we know that theta will be tangent inverse FCA over FBA. We know the values of FCA and FBA. Just substitute in your calculator, take tangent inverse, you will get 77.5 degrees. So this is the solution of this simple question. Hope you understand. If you have any query, you can ask me in the comment section. Don't forget to subscribe my channel and share it with your friends as well.